In this problem, they tell us that ABC is an equilateral triangle inside circle O. They also give us that ADEFG is a regular pentagon inscribed in circle O. And they tell us that CB and EF are parallel. Z is the midpoint of arc CG. Then they tell us that ZC, the segment, is the length of a regular-sided n-gon inscribed in the circle. We want to determine the value of n. Okay, so first of all, let's look at the equilateral triangle. So we have A, B, C. The key thing to focus on is arc AC. What is the measure of that? The thing to remember is that when you have a regular-sided polygon, these central angles here is 360 degrees divided by n, the number of sides. So that means this central angle is 120 degrees, which means arc AC is 120 degrees. If we apply the same thinking to the pentagon, D, E, F, G, we're going to take 360 degrees divided by 5, and when we do that, we get 72 degrees. So that means that this arc right here from C to G is the difference between these two arc lengths. So 120 minus 72, that's going to be 48 degrees, which is the measure of arc CG. But we want to then further break it down in half because it says that Z is the midpoint. So that means the measure of arc Z, let's see, ZG, that's what we're talking about, has a measure of 24 degrees. Now, why is that important? Well, back to our circle, we've got Z and G. This right here is the length of a regular polygon, but we don't know how many sides. But we do know that this arc is 24 degrees. So what we can do is we can work this formula backwards, because n is the number of sides of this polygon, which we don't know. And so that means multiply n to the other side, and then divide both sides by 24 degrees. And when we do that, we get n equal to 15, which is the number of sides of this polygon. And there's our answer, and we're done.